All right, so percent error we're looking at here. To find the percent error, we use this term that's referred to absolute error. Now, what makes something absolute error is we kind of go back to what absolute value is. See that same word in there? And absolute value is? Well, absolute value is the distance from zero. Now, absolute error is just simply, okay, how much is your error? Remember, the result is always a positive answer because it's a distance. So what we're saying here is we're going to take the approximate value, all right, minus the exact value. And when we do this subtraction, we get the absolute value of it because that makes it a positive amount. So again, we don't care if you're over the amount or if you're under the amount, we just want to know how far we are away from it there. So, and this idea is when we talk about TVs, the size of the TV is measured by the diagonal. So it says here, 3 students measured the diagonal of a screen that is said to be 15 inches. All right. So 15 inches here, that's the average amount. That is the exact amount. Find the absolute error for the problem. Let's explain what absolute error means in context. Okay. So the A here is the approximate. So they measured it out to be 15 and 2/8. We know the exact amount is supposed to be 15. So we take the absolute value of it. So 15 and 2/8 minus 15 is just 2/8. Well, what's the absolute value of 2/8? Well, it's still 2/8. Let's look at the next one, 15 and 4/8. Well, okay, before we even just go through the formalities of it there, how far is 15 and 4/8 away from 15? Well, it's 4/8 away. That's it. So we don't really need to go through this fancy process as long as we understand what it means. So this means they're 2/8 off. This means they're 4/8 off. Now, when we look at this, if we go ahead and use the formula, so we take the 14 and 6/8 minus the 15, officially we get negative 2/8. All right, and we can go through the whole math that's behind it, but it's better off saying how far away are we? Oh, it's going to be negative. All those, but wait, look what you get back to. 2/8. So forget this. Do a subtraction problem. I mean, you can if you need to. That. All we're looking at is how far away are you from the exact amount, and whether it's above it or below it, it's always going to be a positive amount. So what we do then here is, and you should hopefully start, as we look forward here, start to see connections to something we've done before. So to find the percent error, if we look at this guy here, this is your absolute error, and we divide it by the original amount. So it's the absolute error. All right, well, that looks like one word. All over the original. All right, and then we change it into a percent, so that's why they're choosing to multiply it by 100. You can move your decimal however you want to go about doing it. Let's go back to something we've seen before. Percent change. Percent change, that was how much did it change over the original amount. Well, that's kind of the exact same thing as absolute error. How far off were you? What was the change in the measurement? It is the same idea. So hopefully we're seeing that connection here. So find the percent error in Taylor's measurement. Okay, so what was the change? In other words, how far off was Taylor? Well, Taylor was off by 2/8. Well, what was the original measurement from a standpoint of, in this particular case, the original is also known as the exact. And maybe that's what we should go back to here. The original and the exact are the same ideas. Well, it was 15. All right. So what we can do here is we can use our friendly calculator. We can change things into decimals here. 2/8 is the same as a fourth. A fourth is the same as 25/100ths. So if you punch in your calculator, 25/100ths divided by 15. All right, and then multiply it by 100 to change it into your percent. You should get 1 6/10 repeating percent. So the percent error was 1.6%. Now, what does that mean? They're off by 1.6%. I should say 1 6/10 repeating percent. So are they off by a lot? Yeah, no, they're not. So not a huge deal from that particular standpoint. So we're going to do the same thing with Connor here, and then for Jordan, let's just do one more. We'll just look at Connor that's there. Connor was off by 4/8. All right, so a little problem there with it. Get back here. There we go. So that was the absolute error, or in other words, a change. It was off by 4/8. The original or the exact amount was the 15. So again, 4/8 is the same as a half, which is the same as 5/10. If we punch that into our calculator and then convert it into our percents, we end up with 3 3/10 repeating percent. So, which kind of makes sense here because here they were off by only 25 hundredths. Here they were off by 5/10. So a bigger amount because they were off by more. So what does this mean? Okay, they're off by 3.3%. Repeating there. C would be the exact same as what's above. So here we go. This is really better. So what's the purpose of finding percent error? Well, percent error lets us know how far off we really were. Okay, so here's the idea. You can be 1 centimeter off when comparing to running a marathon. All right, if you're running a marathon, it's a long distance there. All right, and if you're off by 1 centimeter in that measurement, not a huge big of a deal. Now, what about 1 centimeter off during heart surgery? Well. Now we're talking about something totally different because a centimeter compared to working with the heart versus a centimeter, again, it's gonna have a much bigger difference regarding heart surgery. So that's why that percent error is so important. So let's practice some here. Realtor expected 18 people to show up for an open house, but 25 attended there. So think about it from how much did it change? In other words, versus what actually happened versus what was supposed to happen. And I'm getting 7 there. All right. Now, again, I could do the subtraction problem. I know it's going to be positive there. Well, yeah. All right. I'll go then. And then the original amount, the starting amount, 18 or 25. Well, remember, another word of saying there is actual, the actual amount that happened. Well, it was 25. All right. So officially the work, if you're following the formula, you've got that. Which is 7. I know it's -7, but again, absolute value. So again, I don't mind you jumping right to this, and then we're just converting it there. All right, times it by 4 to get out of 100, so you can jump right to 28%. You could also change it into your decimal, convert it, all stuff that we've been doing here. Okay, so let's go to the next one here. Science class, we got Mrs. Moore's class. They were directed to weigh a 300-gram mass on the balance scale. Tina weighed the object and reported 328 grams. Okay, so how much did it change? Well, the change was it was 28. Now here's the thing: is what was the actual amount? The actual amount. They're told it's supposed to be a 300-gram mass, and you might be saying, but wait a second, 328. Tina put it on the scale. The scale says 328. Well, here we go. They're telling you that this is what it is. Could Tina have made a mistake? Yeah, I think so. Sometimes people are going to make mistakes there. Yeah, all right. So let's change it to our percent. So a little division here. And again, your calculator is saying something like this. When we convert that, that's going to be your 9 3/10 repeating percent. So she was off by 9 3/10%. So close to 10%, which again, depending on what we're talking about, certainly is going to have a pretty big deal there. Oh my goodness, that's it? You got to be kidding me. I thought we had so much more to do. All right there. Again, percent change, very similar to what we've ended up seeing here, to your absolute error, percent error change there. So again, make that connection. It is the change over the original. You just got to watch the original is the exact amount, what it's supposed to be. So those are your synonyms that you're using. That's all that we got for you guys. There's the horn.